All right, last quantitative question. Let's take a look at problem 7. So now we have a system of 3 linear equations, and we're asked to solve it using rref and then also using fsolve. Okay, cool. And again, write a script or function to demonstrate your solution. And so I'm going to solve it first with rref. And what should happen is this is a system of 3 linear equations, so I can use rank to confirm that I have 3 linearly independent equations. And what should be special about my system of linear equations is I should only have one unique solution. So I'll get this solution working for rref, and then I'll use fsolve to solve as well. All right, let's do it. So I'm going to come over here, okay, and I'm going to start by using writing a script. And I guess to solve it with rref, I could do that right within my script. And so let me call this is problem 7, right? We just solved 6. Problem 7, solve. Okay, so I'm going to say first solving with rref. Okay, cool. All right, so when I look at this, right, the equation's already organized so that first comes x1, then x2, then x3. Okay, the only modification I'll need to make is in equation 2 and 3, all 3 terms are present. In the first expression, right, I don't have an x2. So this, right, would be 3x1 plus 0x2 plus 5x3 equals -1. So that when I solve this using rref, what I want to do is I want to create a matrix of the coefficients. So row 1 will correspond to equation 1, then equation 2, then equation 3. So I'll have the coefficients right in front of my variables, x1, x2, x3, so it'll be 3, 0, 5. And then in the last column, I'll have the right-hand side of my expression, right, what it's equal to. Okay. So let's do it. So I'll call it, say, setting up my matrix. Okay, and I'll say m is equal to, okay, the left bracket. Okay, and one nice thing about a script is, remember, I can split this amongst multiple lines, and a new row is equivalent to well, the return for a new row is the same as a new row on my matrix. Okay, so this is 3, 0, 5, -1. So 3, 0, 5, -1. Okay, and I like doing this too because I can even it up. Okay, so this is going to be -1, 5, -2, 12. And my third is 2, -7, 2, -7, 4, -18. Okay, put my bracket up here to close it up. And then just for good measures, I'm going to put a semicolon at the end of each row, right? Even though the return will also count as a row. Okay, but I like when I could do this in a script because I can split it up, and this allows me to, look and check my system of equations when I have my columns nicely lined up like this. Okay, so now solving. Okay, so first I'm going to check the rank. So I'm going to check my rank, and so what I'll do is I'll do, say, R, call it M rank, can be equal to the rank of M. Okay, and then what I'm actually going to check is I want to check to see if M rank, I'll call it M rank check. I want to check to see if the rank of M is equal to, okay, so remember the rank of M is going to determine the number of linearly independent of equations. This is the number of linearly independent equations. So the number of equations that I have in my system, all right, that'll be equal to the number of rows. So I want to see if that's equal to the length of M, and I'm looking at terms of number of rows. So I'll just say row 1, or all rows, first column. So is the number of rows in the first column equivalent to the rank of M? Okay, and if it is, then I'll solve it. And I could do something like this. If rank M is equal to that, then I can solve. Okay, I'll say solving. So if that's the case, then my solution, I'll call it X, is equal to rref. Let me call it MX. All right, in Gaussian form, MX is going to be equal to rref of M. Okay, and my X, right, my solution is just going to be that last column. So I just want MX, and I want all rows, last column. Okay, and I can, I can even display else. I can give a warning or an error. So let me give an error. Number of linearly independent equations does not equal the number of equations. Okay, and in this case we had 3 equations with 3 unknowns, so it'd be the same as checking to see if the number of equations is equal to the number of unknowns. Okay, so if I solve, right, it solves and I get my solution. X is 8, 2, and -5. Okay, great. So this is kind of unnecessary, but sure. Okay, next, solve using fsolve. So if I want to solve with fsolve, I'm going to open up a new file because I'll need an error function. So this could be function res is equal to, and I'll call it error 7. I'll have a single input. I'm going to start by unpacking. And so I'll have x1 be the first element of x. x2 will be the second element. x3 will be the third element. Okay, now my error functions. So the order of the error functions doesn't matter. Okay, now when I write my error functions, I'm going to have to bring the right hand side over to the left so they evaluate to 0 when I find my solution. So this is going to be 3 times x1 plus 5 times x3 plus 1. Res 2 is going to be negative x1 plus 5 x2 minus 2 times x3 minus 12. So I bring that over to the left hand side. Then last is going to be res 3. It's going to be negative 2x1. Nope. It's going to be 2x1. 2x1 minus 7 x2 plus 4 times x3 plus 18. Okay. Call that error 7. And so let me call this, x f for fsolve, and I'll just give it some initial guess, and I'm going to say is equal to fsolve. We saw how we could do, range of random guesses in the last problem. It could be at error 7, and then I'll just use some random guesses before. Now I'll need 3 of them. So if I do rand 1 comma 3, so it's going to generate a vector of random values between 0 and 1. Okay. I will multiply it by, say, 20. So now it's between 0 and 20. And I will subtract 10. So now it's between negative 10 and 10. Okay, cool. So now if I run and solve, hey, equation solved, I get 8, 2, negative 5, all right, which is exactly the same. Okay, great. So 8, 2, negative 5, okay, 8, 2, negative 5, both are the same. Okay, so there is my solution to problem 7, right? And hey, as a test, if I run this with different initial guesses, right, I keep getting the same value. Okay, cool. Let me know if you have any questions, and that's it for the quantitative questions on exam 2.